Okay, good morning, afternoon, and evening, Mr. Dai and Mrs. Faiza, and of course, our friends and families. We're from Numerical Method Assistance Group 4. Here we are to present our presentation about solving system of simultaneous linear equation with open modelica. Uh, I'm here named William Yaskil Tayan, and here's my friend.
My name is Gregory Asher with student number 19063565153.
My name is Robin Brian Hogan with student number 19063013005.
Okay, uh, we're done with the introduction. Let's start our presentation.
So in this presentation, we are gonna discuss the problems and the results. So the first one is the problems. The problem is the members of the truss shown in the accompanying figure have a cross-sectional area 20 centimeter square and are made of aluminum alloy with a modulus of elasticity 70 gigapascal. Using hand calculation, determine the deflection of each joint, the stress of each member, and the reaction forces. Verify your results. So the first step to solve the problems is to discretize the problems into nodes and elements. So here the first one is parameter integer n equals to 8. It is the global matrix uh, that we can find from 2 times the number of points connected. Because the points connected is 4, we times it by 2, we can get the number. Then the second one is the area in meter square. Because the given numbers are in centimeter square, we change it to meter square. It becomes 0.002. And then the modulus elasticity in the problems given is in gigapascal. To change it into Pascal, we can times the given number, which is 70, times the 10 into the power of 9. And then there is the global displacement, and then there's also the global reaction force. And then in the real x n, it is minus 10,000 is the force given in the problem. The next step is to assume a solution that approximates the behavior of an element. Uh, to do this step, we divide into the each truss. So the first, in each truss, there is a degree between truss and the stiffness matrix. To find the degree between truss, we can solve it in the problems. And then there is the K1, it's equals to A times E divided by the length of the truss. The truss 1, it is 1.5, and then the truss 2, it is 1.803. And the truss 3 is 1.5, and the truss 4, it is 1. And then there is integer P1A and P1B and etc. It is the truss that is connected to the truss. Okay, next.
Okay, next we have step 3, develop equations for elements. So we use the declaration of function stiffness matrix. We import the real A as the matrix and output as x for comma 4. Okay, here's the projected real P equals 2 times uh, asinus 1.0. And we set the float error at 10 to the power of minus 10. So the algorithm is basically uh, the formula to operate the inside of the stiffness matrix and setting the elements, the equation for the elements like uh, the the name of the step. So we input the uh, algorithm at the loop to check if the algorithm is not below the float error, and we finally end the function stiffness matrix. And next, step 4, assemble the elements. From before this, the function, now we assemble the elements from the step before. We use the real y 4.4, integer b, integer p1 and integer p2. And the output we want to have is real g b point b. Okay, the algorithm is same from like step before. We use loop operation, and the below is the algorithm to determine the uh, operation inside the matrices. There's total of 4 truss, so we have four four different operation of matrix. And after that, we end local global to end the equation. And step 5, apply the boundary conditions and lots. So we know the boundary conditions and lots from the step 1. Uh, so we operate the matrix G2 times B1 minus 1 point E. The condition is equal 0. And the second one, G2 times B1 point I equals 0. G2 times B2 minus 1 point E equals 0, and G2 times B2 point I times equals 0 too. Okay. After that, we end the loop, and the boundary conditions are stated below the loop. All of them is equal 1. Okay.
Next, for the step 6, we solve a system of algebraic equations simultaneously. So we use the function, the Gauss-Jordan function, by input the integer n, input real a n comma n, input real bn, and the output is the real xn. Then for the protected function, real float error 10 to the power of minus 10. And the algorithm is modelica.math.matrices.solve a point b. For I in 1 divided by n loop, we use the if function. If absolute xi less than equal float error, then the xi equals to 0. And if n4, then the Gauss-Jordan function is n. Then for the step 7, we can obtain other information. So for this step, I use the reaction crisis function. input integer n, input real a n, comma n, input real b n, comma 1, input real c n, comma 1. Then the output is real solution n. And for the protected function is real float error equals to 10 to the power of minus 10 and real x n comma 1. And for the algorithm is x equal to a times b minus c. For I in 1 divided by n loop, if absolute x I comma 1 less than equal float error, then xi comma 1 equals to 0. And if n4 and for I in 1 divided by n loop, the solution I equals to xi comma 1. And for the reaction process is finished. And here are the results that we get. Here is the result for the displacement of the trusses. We can see from this picture above that when t equal to 7 seconds, the trusses has the highest displacement. And for the reaction force, we can see that when t equals to 0 seconds, it has the highest reaction force, and when t equals to 4 seconds, it has the lowest reaction forces. Thank you all for listening.
Thank you.
Thank you,
Gahoy.
bro.